Cholera can turn ordinary thirst into a medical emergency. Severe cases bring torrents of watery diarrhea, rapid dehydration, shock, and death, sometimes within hours if fluids are not replaced. Now, remove the modern explanation. In the first half of the 19th century, physicians could not culture the bacterium, Cressid's genes, or test drinking water with modern laboratory tools. The killer was real, but its root was invisible. The leading alternative was miasma, the belief that foul air arising from filth caused epidemic disease. In crowded, stinking cities, that idea was not foolish. Smell, poverty, sewage, and sickness often occupied the same streets. This field is disease investigation before accepted germ theory. Its best practitioner must do more than notice that people are dying. He must identify a plausible route of transmission, test it against real populations, and point toward an action that protects people. That is difficult because epidemics do not arrange themselves like laboratory experiments. Rich and poor people live in different places. Water, housing, elevation, work, and sanitation overlap. A convincing pattern can still be the wrong pattern. So the comparison rests on 4 tests: a clear mechanism, fair comparison between exposed and unexposed groups, useful intervention, and a method that others can reuse. Saving lives matters most, but a single local success is not automatically a general explanation. The first essential tool was not a microscope. It was the habit of counting deaths consistently. Once many private tragedies became rows in a ledger, investigators could ask whether age, season, place, occupation, or environment changed the risk. The contenders, therefore, arrive from very different directions: mortality tables, national statistics, microscopy, and a maternity ward where doctors themselves appeared to carry danger. Each found part of the answer. The GOAT must connect the parts into a dependable investigation. John Grant began with London's weekly bills of mortality. A tradesman rather than a physician, he gathered decades of uneven death records and treated the collection as data instead of gossip. His 1662 observations searched for stable patterns beneath noisy labels. He estimated population, compared causes of death, and helped establish the idea that health could be studied at the scale of a city, rather than one patient at a time. Grant changed the unit of attention from the bedside to the population, but his tables rarely identified a specific chain of transmission, and they did not create a targeted intervention. He supplied the grammar of the investigation, not its decisive sentence. William Farr made that population approach systematic. At Britain's General Register Office, he helped turn births and deaths into a national statistical service, with rates that allowed places and groups of different sizes to be compared. During the 1849 cholera epidemic, Farr found that mortality rose sharply at lower elevations. He expressed the relationship mathematically and believed it revealed something fundamental about the disease. The result was impressive because it fit both numbers and prevailing theory. Low districts were damp, crowded, and foul. Yet elevation also tracked sewage, water supply, wealth, and housing. The equation described where deaths occurred without proving what carried the disease. Farr's great strength was intellectual range. He weighed environmental, social, and biological explanations, and later evidence moved him toward contaminated water. His flexibility helped make the waterborne account increasingly difficult to resist. But during the crucial outbreaks, his preferred framework still treated water as one factor among several. The statistics were formidable. The causal route remained blurred. A model can predict beautifully and still explain the wrong mechanism. Filippo Pacini attacked the mystery through the microscope. During the 1854 cholera outbreak in Florence, he examined intestinal tissue and described the curved organisms, now recognized as Vibrio cholerae. Pacini concluded that a bacterium caused the disease decades before that conclusion became standard. This was not a vague suspicion of invisible life. It was direct observation tied to the organ most damaged by cholera. Yet seeing the agent did not by itself show how whole neighborhoods became exposed, which water source mattered, or what civic action would stop an outbreak. Pacini solved the identity problem before medicine was ready to connect it to a population investigation. Ignaz Semmelweis faced a more immediate horror at Vienna General Hospital. Women in the physician's maternity clinic died from childbed fever far more often than women in the clinic staffed by midwives. The difference resisted explanations based on climate, overcrowding, or the women's condition. A colleague's fatal infection after a dissection injury helped Semmelweis recognize a connection. Doctors and students moved from autopsies to examinations, carrying what he called cadaverous material. In 1847, he required hand disinfection with chlorinated lime before examining patients. It was a practical barrier between the dissecting room and the delivery bed, supposed before bacteria had become the accepted explanation. The fall in mortality was enormous. Across the relevant before and after periods, modern reviews still find a dramatic reduction associated with the new practice, even while debating the exact size and the influence of other changes. Semmelweis is the strongest rival, because his interventions saved lives immediately and exposed medical hands as a vehicle of transmission. His limit is scope. The evidence was concentrated in a particular institutional system, and his broader causal explanation was difficult for contemporaries to test or transfer. John Snow is the GOAT. His advantage was not one famous map or one removed pump handle. It was a chain of reasoning that joined bodily mechanism, population comparison, local investigation, and preventive action. Snow began with the disease itself. Cholera attacked the gut first, so he reasoned that its harmful material probably entered by being swallowed, applied in the patient, and escaped in intestinal discharges that could contaminate food or water. He published that argument in 1849. It challenged miasma before he had a visible organism to show, and it persuaded few authorities. Snow therefore needed evidence that behaved like an experiment outside a laboratory. South London provided it. Two competing water companies served intermingled households. One company continued drawing from a sewage-exposed stretch of the Thames, while the other had moved its intake upstream, beyond much of London's waste. Because customers of both companies lived in the same districts, often house beside house, their surroundings were far more comparable than separate neighborhoods. The water supplier became the crucial difference. This is a natural experiment. Circumstances assign contrasting exposures without a researcher controlling them. The numbers were stark. In the mixed districts, households supplied by Southwark and Vauxhall suffered about 4.2 cholera deaths per 1,000 people. Lambeth households suffered about 0.5 per 1,000. The dirtier supply carried more than 8 times the death rate. Then cholera exploded around Golden Square in Soho. Snow went from population tables to doors and streets, gathering accounts of where victims obtained water. The Broad Street pump repeatedly appeared in their histories. The celebrated map came after and alongside that inquiry. Its bars made the concentration of deaths visible, but the map was not a magic proof machine. A cluster around a well could be coincidence, unless the investigator tested who drank there and who did not. Snow looked for apparent exceptions. A nearby workhouse had hundreds of residents, but relatively few deaths, and it had its own water supply. Brewery workers in the area largely avoided pump water. Their escape strengthened the exposure argument. He also traced distant cases back toward the same source. A woman in Hampstead, fond of the Broad Street water, had it delivered to her home. She and a visiting relative died, even though their neighborhood was otherwise largely untouched. Snow persuaded local guardians to remove the pump handle. The outbreak was already declining, so the handle did not single-handedly stop cholera, as the neat legend suggests. The action was still rational. It removed a suspected exposure while evidence was incomplete and lives remained at risk. A later parish inquiry described how waste associated with an ill infant could have reached the well through nearby drainage and a cesspool. That supplied a physical path consistent with Snow's theory, though the historical reconstruction is less tidy than modern retellings often imply. The decisive point is triangulation. Snow's conclusion did not depend on one map, one anecdote, or one calculation. The gut-based mechanism, the water company comparison, the household inquiries, the exceptions, and the intervention all leaned in the same direction. Semmelweis produced the more dramatic, immediate clinical result. If this field were narrowest success in hospital infection control, he might win. But Snow explained a transmission route across an entire city and built a comparison that separated water from many surrounding social conditions. Snow was not flawless. He could press a single cause theory too aggressively. Some of his early calculations had weaknesses, and he never saw the bacterium. His contemporaries were not irrational to ask whether elevation, poverty, and other conditions still mattered. Pacini saw the organism, Farr built the statistical state, Grant established population counting, and Semmelweis proved that interrupting contact could save mothers. Snow's achievement was to combine the investigators' full sequence, infer or root, compare exposures, challenge anomalies, and act. That sequence remains recognizable whenever public health workers define cases, number them by time and place, exposed groups, revise a hypothesis, and remove a suspected source. The equipment has changed. The disciplined logic has not. Jon Snow deserves this GOAT title because he showed that an invisible killer could be cornered before it was visible, not by one brilliant picture, but by making mechanism, numbers, exceptions, and action answer to one another.